because today we are going to get a new assignment today, but I want to look at Friday's assignment, especially because I know not many people turned it in, especially after the fact that there was no video for you to watch like there was supposed to be. So I want to just go over like how to set these problems up and identify the information we're trying to do. That way we can actually solve these problems because it's actually something we know how to do for the most part already. So these problems really don't have too much involved in them after the fact that we are just need to identify a couple extra things. So I am just gonna go down a little bit further, just down to here, and I just want to ask a couple things. So let's start off by, if I have grams of, let's say, let's just go with oxygen. 5 grams of oxygen, how do I convert to moles of oxygen? What do I have to use to go from grams of oxygen to moles of oxygen? Who can tell me? Something we did first semester. We reviewed it last week. Maybe it was on Monday. How do I go from grams to moles? What will we divide by? Because I do like that we're going to divide by something. What will we use to divide?
You divide by molar mass?
The molar mass, perfect. So I'm going to call that M for molar mass. So to go from grams to moles, or even to go from moles to grams, either way, if it's the same compound, we have to divide or multiply by the molar mass. So we're using that molar mass to convert from one to the other. All right. And then on Thursday, at the beginning of the day, we talked about a different thing. And so let's say I have my equation. All right, I have this equation. What if I wanted to go from moles of oxygen to moles of water? What would I use to go from moles to moles? What did we call that one? What will we multiply by? Because I like that we're multiplying by something, but what are we going to multiply by? So it's not the molarity, but I do like that word for something in the future. But if we're trying to go from moles of one thing to moles of another thing, do you guys remember what we have to use? It was on Thursday. We did a few practice problems on it. Something to do with these numbers in front here, those coefficients. You guys remember what that one was called? It also started with mole. Mole what? Mole ratio, perfect. So we're going to use our mole ratio to go from moles of one compound or element to moles of another compound or element. But we have to use that mole ratio from our balanced equation. And so remembering that our mole ratio are going to be those coefficients from the balanced equation. So our mole ratio is our coefficients from our balanced equation. And it's how we get from moles of one compound or element to moles of another compound or element. We use our molar mass to go from grams of a compound or element to moles of that same compound or element. All right. Now, what if I asked you, we're still going to be using this wonderful equation up here. What if I asked you to go from grams of oxygen to moles of water? Can we do that? Anybody know any steps we can use to get there? What do we use to convert that one? All right, by a show of hands or reactions, I want to see a thumbs up if we think that's possible and an X if we don't think that's possible. At least if we don't think it's possible in one step. All right, I've seen quite a few X's saying it's not possible to do in one step. Do we think we can do it in 2 steps? Same reactions, thumbs up or X, 2 steps. All right, I got quite a few X's still. About 3 steps. Got some thumbs up. Okay, so what would the first step be? If I were to then take my first step, what would I go to? I would go from grams of oxygen to what? What can I convert grams of oxygen to? Moles, perfect. And so I can convert grams of oxygen to moles of what? What would my moles have to be of? If I'm starting over here and I had grams of oxygen, what would I have to convert to if we can't do this? Moles of oxygen, perfect. So I'm going to convert to moles of oxygen. All right, so now my next question, can I go from moles of oxygen to moles of what? All right, I've heard yes and no. So if you think yes, somebody tell me what they think how we're going to get there. And if you think no, I want you to tell me what my next step is going to be too. How can I get from moles of oxygen to moles of water? Or what's my next step after converting to moles of oxygen? All right. Somebody told me I can go from moles of oxygen to moles of water using the mole ratio. So I can use the mole ratio to go from moles of one element or compound to moles of another element or compound, as long as we have a balanced equation. So I can do this one in 2 steps. So remind me again how to go from grams of oxygen to moles of oxygen.
You divide by molar mass.
We use our molar mass, perfect, or that atomic mass, good. And then we use our mole ratio to go from moles of oxygen to moles of water. So these ones are two-step problems if we're trying to go from moles or grams of our, from going from grams of one element or compound to moles of another element or compound. So we have this way of finding this information using our smaller ratios from up here. So using those ratios we came up with to go one-step problems, we can now use it to go to two-step problems. All right. Now let me ask a different question. If I wanted to go from grams of oxygen to grams of water, can I do that in one step? Can I figure out how many grams of water I'd make based on how much oxygen I have? Can I figure that out in one step? No, all right. So I can't do this one in one step, just like before. Can anybody tell me what's the first thing that they think we're going to do? What's the first thing we're going to convert to then? What can we figure out? If I know my grams of oxygen, what can I figure out based on those grams? What's the only units we can compare between two different elements or compounds? We need to use our molar mass to go from grams to moles. Perfect. Because moles are the only things we can compare between two different elements or compounds, because moles are representing 6.022 times 10 to the 23rd particles. So it's just the amount of atoms or particles we have present, not a mass that's not comparable. So we're going to convert to moles using our molar mass. Now, can I go from moles of oxygen to grams of water? All right, I heard no. We can't do that either. What can I go to if I have my moles of oxygen? We can go to moles of water though. So we still want to use water because we're trying to find grams of water, but we can go to the moles of water. And what do we have to use to go from moles of oxygen to moles of water? What do I have to use to compare my moles of oxygen to moles of water? The mole ratio, perfect. Can I go from moles of water to grams of water? I can do this one. What do I have to use to go from moles of water to grams of water? The molar mass, awesome. And these are the same, right? These are the exact same numbers. I use the same molar mass twice? What? Why not? I heard they're not the same. So what would that one on the left be? What would this one be? What molar mass would I use? The molar mass of what? the molar mass of oxygen, because that's what we're trying to use to convert grams of oxygen to moles of oxygen. We would use the molar mass of oxygen. What about over here? What would I use for my last step? Going from grams of water to moles of water to grams of water. What molar mass would I use for that one? The molar mass of water. Perfect. Does this stuff make sense as to why there's so many steps? All right, I got a few thumbs up. Nobody said no. So are we comfortable finding those things, these steps, the molar mass of oxygen, the molar mass, or the mole ratios, and the molar mass of water? Are we comfortable finding those types of information? Molar masses and mole ratios. All right, got a couple thumbs up again. Awesome. Do you guys want to do some practice on this worksheet together? Awesome. So let's take a look at, you guys want to do number one? Is that one okay with you guys? Awesome. Got some thumbs up. So we're going to do number one first. So it says in this reaction between zinc hydroxide and phosphoric acid, we have 5.9 moles of zinc hydroxide is used in this reaction. How many moles of each product are produced? So the first thing that it's asking us to do is, because it didn't give us this, we need to find a balanced equation. So we know, what are the two reactants going to be?
Zinc hydroxide and hydrogen phosphate.
Perfect. So zinc hydroxide plus the H3PO4. All right. So what kind of reaction does this look like? Is it going to be synthesis, decomposition, single replacement, double replacement, or combustion? What do we think? Double replacement is perfect. So what two things are going to switch spots?
Zinc and hydrogen.
The zinc and the hydrogen. Awesome. So let's have zincs first. So zinc is going to come over with the PO4. We got to remember that zinc has what charge normally? Who remembers the charge for zinc?
Two.
+2. Awesome. What's the charge on phosphate?
-3.
-3. So what is my compound? What's my formula going to be?
Zinc 3, phosphate 2.
Awesome. Plus, all right, now we have an H and we have the OH. What's the charge on my H?
One.
+1. What's the charge on my hydroxide?
-1.
-1, which means what is my formula going to be for that one?
HOH or
HO.
H2O.
Perfect. HOH, or if you want to keep it as H2O, that is also acceptable. All right. So now we have our formulas. Now we got to balance our equation. So let's balance this equation. Everybody come up with a balanced equation? Everybody know how to balance this one? All right, how about this? Are zincs balanced? The ZNs, do we have the same number on each side? No, okay, so which side has less, reactants or products? My reactants, so how do I make them balanced? What do I have to multiply my reactant side by? 3, all right, so we put a 3 in front here. All right, what's next? Look at our hydroxides. This is the next reactant. So our hydroxides, are they balanced? No, which side has less? Reactants or products? My products, how do I make them balance? What do I have to multiply my product side by? By 2, all right, so I put a 2 here. They're the same now? Are my hydroxides the same number now? All right. Careful on the hydroxide, the 3 distributes into the hydroxide 2. So how many hydroxides do we have on our reactant side? Not 2. How many do we have? We have 6. So this one needs a 6 in front to balance out with our reactant side. So now our reactants and our products for hydroxide and zinc are balanced. What about hydrogens? Are the H's balanced on both sides? No, okay, so then which side has less, reactants or products? All right, our reactants have less, so what do I have to multiply my reactants side by to make sure my H's are the exact same? Two, perfect. So this 2 goes in front. All right, so now my H's are 6 on each side. What about my phosphates? Do they match? Do the same number on either side? We do, so now we are balanced. Perfect. And yes, normally I would write out the work, just not enough room because I was writing too large. So the next step says write out, and before we do the next step, part B, yes, you do need to figure out if they're soluble or insoluble. I kind of skipped that step on this one, and I apologize. This one should be aqueous. And if it starts with this H like this one does, this is always going to be aqueous, like HCl, H3PO4, H2SO4, HBr, almost always aqueous for that case. And we're going to make that assumption that they're aqueous. Then this one is going to be insoluble, so it's our solid. And of course, this is our liquid. And I kind of skipped over that step, and I apologize for skipping over that, but you do need to figure out solubility, especially when we're doing double replacements. We need to make sure our reactions are happening. But back to step B. So it says write out our steps needed to answer this question. So when I say write out the steps needed to answer this question, I'm talking about these things down here. So like, are we going from grams to moles, grams to grams, moles to moles, moles to grams? What are we doing? So in this problem, what are we starting with? Just like the units, what are we starting with?
Moles?
Moles, perfect. So we're starting with moles. And let's be specific about what kind of moles we're starting with. Moles of what?
Zinc hydroxide?
Of zinc hydroxide, perfect. Moles of zinc hydroxide. All right, and what are we trying to figure out at the end of this problem? What does it say we're trying to find?
The moles of zinc phosphate and water?
Awesome. So we have two problems here, not just one. So we're going to write out the steps twice since we have two sets. So we need moles of zinc phosphate. And we're going to separate this. We have another problem, moles of zinc hydroxide to moles of water. All right. So we have two problems here. And so let's focus right now on the left one. So the moles of zinc hydroxide to moles of zinc phosphate. How do we go from moles of zinc hydroxide to moles of zinc phosphate? What do we have to use to go from moles of zinc hydroxide to moles of zinc phosphate?
Mole ratio?
We're going to use the mole ratio. Perfect. All right, now let's look at the other one. How do we go from moles of zinc hydroxide to moles of water? What do we have to use?
Mole ratio?
We're going to use that mole ratio again. Awesome. All right. So now in step 3 or step C, it says write out the conversion factors needed. So we've identified those conversion factors. we need the mole ratio up here, and we need the mole ratio up here. So let's write out each of those mole ratios. That way we know all the information needed to solve our problems. So what mole ratio do we need for, let's call this one A. What do we need for A? What's our mole ratio going to be? How many moles of zinc hydroxide are needed for the reaction to happen? How many moles of zinc phosphate are we going to make? Or better yet, where do we get our numbers for that mole ratio? Who can tell me?
The balanced equation.
The balanced equation. What numbers do we use from that balanced equation? Awesome. I was given numbers. We used the coefficients. Perfect. So we're going to use those coefficients. So the moles of zinc hydroxide is going to be that 3 right up here. So 3 moles of zinc hydroxide are needed for that reaction to happen. And how many moles of zinc phosphate are we going to make? If we have 3 moles of zinc hydroxide, how many moles are we going to make of zinc phosphate?
One.
1, perfect, because we use the coefficient of zinc phosphate, which is 1. So 1 mole of zinc phosphate. Any questions on how we got those numbers? All right, let's do it for part B then. So the second one. So moles of zinc hydroxide to moles of water. How many moles of zinc hydroxide do I need to make this reaction happen again? 3, perfect, just like before. 3 moles of zinc hydroxide to make the reaction happen. How many moles of water are we going to make?
Six.
We're going to make 6 moles of zinc, or sorry, 6 moles of water, because we're using the coefficient in front of water for that one. So we're going to have 6 moles made of water. All right. So because there's only one step, we only need one divider in our railroad tracks or our lattice structure. So we're going to make our first one for A. Because there was the one step, we use one divider. All right. What goes in our top left of our problem every time? Are awesome. So we're going to put those moles in the moles of what? We're using the moles from the mole ratio, the moles from somewhere else. How many moles are we putting up here?
Three.
Careful, we don't put 3 up there. So what do we put in the top left? Every single time. What are we always going to put up here when we're setting up our railroad tracks? Starts with a G.
Our givens.
Our given, perfect. We're always putting the given up here, no matter what. Doesn't matter what kind of problem we're solving, if it's stoichiometry, if it's just random conversions with metric system, anything. Our given always goes up here. So the given always goes up there. And what is our given for this specific problem? What are we starting with? What's our given for this problem? The 5.9 moles of zinc hydroxide. Good. So 5.9 moles of zinc hydroxide. And we got that number from our problem. The given comes from our problem. So way up here. All right. So now that we have our given, we have to use our conversion factor to go from one unit to the other. So our conversion factor goes in our next column. And so for problem A, we're trying to go from moles of zinc hydroxide to moles of zinc phosphate using what? How do we go from moles of zinc hydroxide to moles of zinc phosphate? What do we have to use? The mole ratio. All right, so we're using this one for problem A. We have 3 moles of zinc hydroxide to 1 mole of zinc phosphate. Do I put the 3 moles of zinc hydroxide on the top or the bottom of my next column? On the bottom, perfect. So I'm gonna put my 3 moles of zinc hydroxide down here. That way those units of moles of zinc hydroxide get canceled out. And we have the 1 mole of zinc phosphate on top. That way our units turn out to be zinc phosphate. And now all we have to do is multiply everything on the top and divide it by everything on bottom. So we have 5.9 times 1 divided by 3. And what do we get? All right, we got 1.9667 moles of zinc phosphate. And if we make sure we're in sig figs, how many sig figs do we have to use for this problem? Two, which means perfect, which means we're going to round this number to 2.0 moles of zinc phosphate. All right, so that was part A, which part B, you still need to do, which is just going to be the same thing, except for this time, now you're going from moles of zinc hydroxide to moles of water instead of moles of zinc phosphate. I'll stay on in case you guys have any questions. Otherwise, you guys are good to go. Try and work on this worksheet. Try and finish this one up today if you can. Because then tomorrow you can start your other worksheet that you'll have tomorrow and Thursday to work on.